a little bit about me. I chair the board of directors of Smart Precinct, which is it's actually been in the works for about 18 months, but we launched in September. The organisation has financial backing from Townsville City Council, state government, and its mission is basically to develop an ecosystem of high growth companies based in Townsville, but that serve the world. I'm sure, as many of you know, it's hard to find interesting jobs for, in the tech world in Townsville. Companies like SafetyCulture have had to shift a big part of their workforce and develop their offices outside of Townsville. We want to develop an ecosystem here, so there are opportunities, there's competition between companies. That's the mission of Smart Precinct. So I do that as a volunteer. I've been working with the organisation for about 2 years. My background is I began my career, I got really lucky and I got a contract in the UK working on the world's first mobile banking application. This was back in 2003, pre-iOS, pre-Android. The platforms we were using were called Symbian, was the C# from Nokia, and J2ME, which is a Java platform. The project was run by the Royal Bank of Scotland, a pretty simple little app, but it exposed me to a ton of stuff around mobile development, as well as building back-end services, secure back-end services. I then spent some time at Optus, helping them develop their data platforms. Went back to the UK, worked at Sky Television doing a lot of their online commerce stuff, worked on a team there. Following that, I founded my own company, which was, the intellectual property was acquired by BBC Worldwide, which is now known as BBC Studios. And as part of that deal, they agreed to basically fund a new startup, helped me get set up with my co-founder in San Francisco. And we built a team. We were there for 4 years before we were ultimately acquired. And then in 2014, my co-founder and I returned to Australia. We didn't have a problem we wanted to go and solve, but we had all these skills in mobile and data and back-end and early stage products. And so we decided to found Fierce Ventures, which is the vehicle that I still operate out of. And for about 4 years, we worked with founders who were experts in some domain, but didn't necessarily have tech or design skills, and we built a pretty good business doing that. We built a small team here. I can see Lachlan was our employee number 4. He's in the room. And in 2018, we decided to change direction again. And since then, we've basically building out our own intellectual property. So I've got a broad range of skills in tech. I've been exposed to a lot of different things. And being an early stage founder myself and working with founders, I've realized the importance of the decisions you make early on can really haunt you long term if you make the wrong decisions, particularly around tech stack. And the reason you want leverage as a founder is you want to be able to do as much as possible with as few resources as possible. You don't want to have to go and raise lots of money, give away a lot of equity and control, give away a potential upside. If you're going to go through the heartache of building a software company, but building a startup. So leverage is really important. So I want this to be a discussion. If anyone has any questions or wants me to clarify something, I'll be honest, I've been super busy building products, so I haven't prepared beyond the slides. So I'll be shooting from the hip. But please do interrupt me if you want to have a chat or want me to answer a question. I haven't even timed it, so Tristan, if you could let me know, say 7:05, I'll aim to wrap up. So I'm covering a few different things here, generally, from the bottom of a stack all the way up. I could talk for hours on each of these subjects, and I'm happy to come back at another time if there's interest. This is, just a short disclaimer. This is my opinion based on my experience, and I might be wrong. If you think there are things that I could be doing better or looking at differently, please let me know. Always looking for new, interesting ways to do things. So, as a founder or someone that's building a product, every decision you make is a compromise, and those compromises, some things might get you up and running quickly, but might have long-term negative effects. Some technologies might be harder to learn or train your team in, but long-term, will give you the power you need. And the kinds of questions that founders tend to ask themselves when they get beyond prototype stage is, which language do we choose? Which database do we choose? Which frameworks do we choose? Where do I host my application? What are the processes and methodologies that we apply to the team? With the selection that I make, can I scale my team as well as the code base? can my application scale? Can the stack I choose scale? They're all different kinds of things that need to be considered. And one thing that I think is really important is, are the people working with the tools that I've chosen happy to do so? Or do people leave my company because the tech stack is painful to work with? And obviously the most important thing is, are customers happy? And the decisions you make early on impact all of these things. So let's just start where most people start, is programming language. You'll say, what language is it written in? Well, there are certain characteristics that you want from a programming language. Now, I have first-hand experience building production systems in all of these languages. Primarily, Java was the initial language where I spent a lot of time, but I've been lucky enough to work on great projects using all of these languages. So I've had fair exposure to a lot of different tools, a lot of different frameworks. One skill that I feel I've been able to develop is the ability to learn a language quickly, learn its primitives, learn its conventions, which is a skill I encourage any developer in the room to invest time in. Don't get pigeonholed. Expose yourself to new ideas, new ways of doing things. So I think as if I was getting to pick a language, I want the certain characteristics I want. I want it to have a simple syntax and a small core library. I don't want to have to learn lots of different things. I want it to be very focused on the problem that it's able to solve. I want it to be functional as a first-class feature, so that functional languages tend to be really good at managing data, and as the amount of data that we have to wrangle as software developers grows, it's a really important part of the language that you choose. I want transactional memory to be managed by the software itself. Very few languages actually have this baked in, and if you want to do STM, if you want the STM, you have to basically use a third-party library, an open source library. I want immutable data structures. So most languages, data structures are not immutable in nature, and that makes doing any kind of concurrent programming very difficult to do. You've got to worry about locks and transactions and all kinds of painful things. I'd rather that was baked into the language. Ideally, I want it to be interoperable with either the JVM, the Java Virtual Machine. Now, the JVM is not Java. It's the machine that that code compiled to Java bytecode can run on, or JavaScript, or .NET. So the language that I pick, I want it to be able to run on one of those three platforms. I also want the language to have what are called macros. I want it to be extensible. So if the language designer didn't build something into the language, I want to be able to extend the language in my own way. I want it to have polymorphism, and obviously, as I mentioned before, primitives with concurrency. And I want it to be fun to work with. I think that's a very important part of it. So, based on my experience, these are some of the features, some of the languages. So, you can see not every language ticks every box, but you can get a general sort of sense of it. So, I presented here before a couple of years ago on Clojure. I've been using the language in earnest for about 5 years. I have worked with other languages in that time, but Clojure's, if I get to choose the language that I'm working with, Clojure's the language that I'll pick. So I'm gonna sort of skim over the language and its features before moving on to something else. So again, it ticks some of those boxes that I spoke about before. It has a very simple syntax. It's very easy to learn, in my opinion, and the more experienced you are as a developer, the easier it is to learn and appreciate its syntax. It's homoiconic and functional. So homoiconic means the language itself is a data structure, and it's a fully functional. STM is built into the language, so anytime you're doing any kind of memory management, you don't have to worry about transactions or locking. It has persistent immutable data structures. So immutable data structures never change. And persistent means that when you do make a change to them, and I know that sounds, but when you make a change to it, it keeps a record of the changes over time. So what it means is if I'm in a thread making a change to a map, I don't have to worry about locking that object or worrying about transactions. That's all baked into the language. And now, of course, you can change the data structure. You don't need to worry about somebody on a different thread, changing it while it's under operation. It has a REPL, so it has very great built-in interactive programming into its development environment. It compiles to both Java bytecode and JavaScript. And what's really great about this is, so the 3 file extensions there, CLJ is for Clojure files that compile to Java, bytecode, JS is obviously compiles to highly optimized JavaScript, and it uses the Google Clojure, which is just a coincidence with an S, compiler. And then what you can actually do in Clojure, and the more experienced I get with the language, the more I find myself doing this, and all the great Clojure libraries, they'll write it in a format called CLJC, which compiles to both Java bytecode and JavaScript. And this is a key feature, in my opinion, of the language, because it means I can write validation code, I can write business logic in one place, and I can use it on both front end in JavaScript or back end. I'm not repeating functionality and tests and effort on both front end and back end. I'm able to write code that can run in both. It has macros, so it's easy to extend the language. It has many polymorphism primitives, depending on what you're looking to do. It's succinct, and the language was designed from the ground up to wrangle huge amounts of data and to be able to reason with data. And it's, in my opinion, the most fun language to work with. Luke's also joined us. He was employee number 5 at Fierce, and I know Lachlan's probably, I think he's still working with Clojure. Maybe Luke who's joining SafetyCulture can convince SafetyCulture to try some. So it has very simple syntax. You'll often hear the argument, mostly from people who never used the language, that there are a ton of parentheses. There was everything is a data structure, so that's just a list. The first argument in the list, first field in the list is the operator, and then the parameters. That's the very basic syntax. Obviously, it gets more complex, but if you understand that, you understand 90% of the language. You can represent basically anything in a data structure in Clojure. The couple of examples, real-world examples. And just to show you how succinct it can be, another developer did a presentation here on functional programming a couple of years ago, and they showed the example of taking the mess on the left and using functional programming to get the result on the right, which is obviously a lot neater. And I took that result and I put it up against Clojure, and I managed to get it one line shorter, and it's actually, if you count the parentheses, it's got fewer parentheses. So again, if you look at the syntax there, it's just a list. And the great thing about dealing with code that's just data is you end up thinking only in data. I'm not thinking about where to put the bracket or how many spaces to use. It's all just a single list. So that's my Clojure rant over. So let's think about data, which might be the next layer of the stack. You might choose Clojure as your programming language, which is what I would choose. Now we've got to choose a database. Having worked with a number of different databases over the years, this is a very important decision, and one that you want to get right. I know that SafetyCulture's had, you guys worked with MongoDB for a while, and I know it's given you guys some headaches. Those kinds of decisions, you want to make sure that you're getting them right as early as possible. So questions you might ask about, you want to know with your database, is the data safe? Can you query it and write easily enough? Can you do complex queries? As your data grows and you want more interesting analytics and features, you want to be able to write complex queries. Can it scale? Is it fast, and does it remain fast as your data set scales? Can you analyze the data? If there are problems with queries, can you performance tune them? Does it need constant tuning, or is it fairly resilient? And is it fun to work with? So my database of choice at the moment, if I get to choose, is a database called Datomic. It's from a company called Cognitech. The founder of Cognitech is a guy called Rich Hickey, who's also the founder of Clojure. So there's clear alignment between Datomic, as I'll show you, and Clojure. Datomic's actually an amazing tool, and I'm going to take you through some of its features that no other databases have. It's transactional, and transactions are ACID. And it gets around this by doing one rather than worrying about distributed servers writing to some sort of transaction log and worrying about locking. There's basically one thread that's responsible for all writes, and it writes the transaction log. Every thread in the cluster goes, every write in the cluster, writes are called transactions, goes through that single thread. So Datomic is not write optimized, but it is read optimized. So in the design, I mean, it can still write a tremendous amount of data per second, but it's optimized for reads, and I'm going to show you a few how it does that. The data is indelible, so once it's written, it's never overwritten. So if you think about a SQL database, if you had a mobile number in a column and you were to change that value, what was there is actually removed forever. It's lost. Datomic takes a different approach where the data is never actually overwritten. You can't overwrite it. Everything is seen as a series of facts. Every change in the database is a fact. It has a very simple query language, extremely powerful, which I'm going to show you an example of in a minute. But basically, the query language itself is just a data structure, and as I've shown you, that's very easy to represent in Clojure. It's embedded, so it's not a traditional client-server model where you might have a database server with a whole lot of clients querying it. The query engine and the cache sits inside your application. So when you're querying and you're running a query, you're running against the version of the engine inside your application. I'm going to show you how it does that in a second. So when Datomic was first launched, I think back in 2014, it was an on-premise product, but now Cognitech have basically moved it with their emphasis now being on a cloud-based, AWS-based product. And I'm going to get to why that's great in a second. It scales elastically, high availability. So you can actually store, with the on-premise version, you can have your backend, either Postgres, Cassandra, there are a whole lot of databases you can actually use as your underlying storage mechanism. If you choose the cloud version, which is basically, it's not managed by Cognitech, but they provide a CloudFormation template in the marketplace. You run it on your own infrastructure. They set it all up for you inside a VPC with all the rules and all the IAM permissions and roles, and everything gets set up for you using this CloudFormation template. But it's stored on DynamoDB, a combination of DynamoDB, EBS, and NS3. It has great monitoring and deeply integrated into AWS CloudWatch, alarms and notifications, and it's very reasonably priced for a single node cluster, which is a one machine cluster, which is what you would need for a developer. It's $1 a day, and you can start it up and shut it down at any time. And it's extremely fun to work with. The reason it's fun to work with is once it's set up and working, you don't feel like you're querying against a database that's sitting on another server. It feels like you're doing all the work inside your application. Datalog is the querying language. It's declarative and logic-based. It's much simpler than SQL. And again, you're working in data structures. You're not thinking about strings of text that you have to construct. Because it's data structures, you don't have to worry about interpolation or sanitization or SQL injection attacks. It's fun to work with. So this is an example of Datalog. Basically, I'm finding the name and duration of a track where, it's done a join between an artist and the tracks for the artist. There's a one-to-many relationship in there, but it's quite easy to understand once you understand the data structure syntax, what it's querying for, and that will return all tracks where written by where the artist was the Beatles. And obviously, the joins are implicit. You can join across, across the structures quite easily. So one of the decisions you'll have to make as a founder is where to host, and moving between cloud providers is very painful. So you want to make sure you get that decision right early on. Basically, there are three main options: AWS, which has I think 32% of the market. Azure, which is 20%, and Google Cloud. AWS is the beast. It has over 200 products and services in its suite. It's been around the longest. They had a 7-year head start on Azure. But because it's a beast. It can be a pain to work with. I built my first product on AWS the year after it was made available in the US. I was in the US, and you can end up spending a lot of time learning each of the services. But I think that work is worth it. And there are now wonderful tools like Terraform. There are online tools for managing your infrastructure. But I'm going to show you something that Datomic provides, a feature of Datomic, which makes that a lot easier. The key thing about AWS is it's really all API driven. All their products are API first, and then they build them into the dashboard, the console. You can often get access to features through the API that are not yet available or will ever be available in the dashboard. It does require reading API docs constantly and sometimes even reading code, but they're all documented and available. So Ions is a feature of Datomic, and really what Ions lets you do is run your application in the same Java virtual machine process as the database itself. For me, this was revolutionary. Imagine being able to write your program and run it in the same process as Postgres or MySQL or RDS. Why this is revolutionary is because you no longer have to worry about connection pooling and the kinds of queries that you can write against the database, which is just in memory, on your node. You can basically do anything because you have direct access to that memory on that node. So Ions is, as I mentioned before, so what Ions actually does is once you provisioned your database using the CloudFormation template that Cognitech publishes as a product on the AWS Marketplace, Ions will take care of basically setting up all the infrastructure for you. So, all the S3 buckets, it'll set up a code deploy application. There's a command line client similar to like Heroku, where you get a client to do deploys. It will make sure, it'll create, when you push a new revision, it stamps it with the hash, and you can do repeatable deploys. It takes care of all of this infrastructure, which in the past you would have had to worry about yourself. And chances are, if you're in a small team, you're not an expert, you're going to miss something, particularly around security and access to these resources on AWS. And that's basically the greatest risk, is that you configure something incorrectly. You have a rule somewhere that's not right. So Cognitech basically take care of all of that for you. Plus, they take care of all the scaling. So, and the scaling is based on throughput demand. So, the rules that you can set up, basically it'll just trigger a new instance for you. It'll deploy your it'll set up the database, deploy your application. It's truly a wonderful feature. And being able to run your code directly in the same process as the database opens up a world of querying possibilities. You get to focus on your application. So as I mentioned before, I'm not thinking in SQL, and I'm not thinking about indexes or joins. I'm just telling basically Datomic what data I want, and it figures it out for me. I mentioned that you're running your transactions and queries in the same process. Datomic Ions exposes itself through other lambdas, or you can define HTTP endpoints through API Gateway. And again, that's all simple configuration directly in the app. And again, it's all just Clojure. So I'm writing backend code, Clojure, my database queries in Clojure, my front-end code in Clojure. I don't have to think about, basically I just have to reduce the number of things that I have to think about. I was going to touch on this. So Fulcru is so we've covered database, we've covered stack, we've covered where it's being hosted, we've covered programming language. Now, Fulcru is, if you're building a single-page web application, which most business applications tend to be today, or a web application of some sort, often they're single-page apps. Fulcru is it's basically a programming system for building single-page apps in Clojure, and it solves a number of problems that are exposed by React. So if any of you have worked with React before, and other Clojure frameworks. it tries to solve some of those problems too. So it's full stack. It's front end and back end code. It's graph centric, which means one of the challenges with React is composing your components in a way that matches your data structure, and GraphQL goes a long way to solving that. But it too has issues. So Fulcru basically models your data structure and your changes in the same way that Datomic does, and it does this by creating exposing on the client in your JavaScript compiled code a normalized database that you then can query and populate using some very simple primitives inside the framework. And again, all you're doing is thinking about data. And because typically when data comes from GraphQL, it's denormalized. What Fulcru will do is normalize it into a relational type structure where you have a table plus your rows and then references between them, so that each component then can query that database for the data that it actually wants, rather than being fed from its parent. Again, it's just Clojure, and it's a lot of fun to work with. I will say that I've been working with Fulcru for about a year, and it has a very steep learning curve. But I think all of these tools do, but they all build on each other. So, but yeah, I found them to be extremely productive, and yeah, extremely useful. So there is a catch, and the catch is it's hard to find developers with the skill set. But I found, and the strategy we took at Fierce when we were building a team was either we hire the smartest kids out of JCU, we wanted them in Townsville, and be able to train them in the stack that we were working with, or we can hire and find engineers with a lot of experience who understand some of the subtleties of the work we're doing. And that worked to pretty good effect. These guys were unbelievable in how fast they could learn the stack, how fast they could become productive, and how fast they could learn with almost no experience to appreciate the tools. But yeah, the catch is basically finding people who can work with the stack. And as an example, I've been working on a product for 6 weeks. We did this on this exact stack, and we had a lot of the structure and frameworks put together from previous work. But we designed and built that product. And if you want to have a look at it, you can go to. Let me see if I can find it for you. You go here and register your interest. We've done a soft launch. We're launching to the world in 2 weeks. This is a platform for boutique investors to either find people to invest on behalf of, or for companies to find investors who might want to invest in whatever their niche is. This product is fully built on Datomic in AWS with Fulcru. So this took us 6 weeks to design and build. I'm happy to show you, code or how we did it if you want to see. It's certainly the fastest and highest quality product that I've built, in my career. So, and again, this was just a two-person team. So I feel like this stack in the right hands can give you a lot of leverage. That's it. Any questions?